Hello guys, so today we are going to solve the next problem in our CSES problem set playlist. So this problem is named as gray code. Here we have to print the gray code. Now what exactly gray code is? We have to print the numbers from 1 to n in binary format such that the the alternate consecutive numbers differ exactly in 1 bit. That means their Hamming distance is 1. This is also called Hamming distance. So let me explain what the question says. So for example, if n is, let us say, 1. So if n is 1, then there will be 2 to the power 1 total number of numbers in binary. So that will be 2. So which are 0 and 1. So as you can see, their Hamming distance is 1 because only 1 bit is changed. Okay, so let us take next test case n is equals to 2. So total numbers till for 2 bits will be 4. So here first number is 0 0, then 0 1, then 1 1, then 1 0. So as you can see, if I jump from 0 0 to 0 1, only 1 bit changes there. Then from 0 1 to 1 1, only 1 bit changes there, like this bit is changing. And then from here to here, only 1 bit is changing. So this is how we need to print all the numbers, and this is also called gray code. So how should we approach this? For example, if I have n is equals to 3, so what should be the procedure? So let's start from the beginning. For n is equals to 1, we were having 0 and 1, okay? Or like I should say, I am having 1 0 over here. That doesn't matter because it's 0, so I can put any number of zeros. It will still remain as 0 and 1. Now for n is equals to 2, what I am doing is, since I have to change only 1 bit, so the next number after 0 1 should be 1 1 because I have to change only 1 bit. If I change this bit, then it will again go to 0 0. So I am left with this bit only. So I just change this bit. So it gave me 1 1. Now from 1 1 to the next number, I can go by changing, taking this one as constant and changing this one. So this gives me 1 0. So this is how I got for n is equals to 2. Now for n is equals to 3, what I can do is, like, there are all zeros. Now for n is equals to 3, I will put 1 and just like copy this string. Now for next number should be obtained by keeping a 1 here and then copying this string. Since from here to here only this bit is changed, now from here to here this bit is changed. Now for next number, what I am doing is I am copying, changing this 0 to 1 and copying this number 0 1, and then next number is 1 0 0. So as you can see, only 1 bit is changing. So essentially what we are doing is, uh, I have, for example, 4. Now for what I'm doing is I'm just changing 0 to 1. For to In this case, I will change this 0 to 1 to get the next number. And now, since this is for n is equals to 1, 1 case, okay. Now for n is equals to 2, what I will do is I will just change these zeros to ones in the reverse order. So I will start iterating from this one, change this position 0 to 1, so this becomes 1 1, and then since I'm iterating in reverse, so 0 0, and then this is changed to 1 1 0. So as you can see, I got answer for n is equals to 2. Now n is equals to 3, what I will do is I will start iterating in reverse from this direction to here, and I will change this uh, 0 1 2 second bit to 1. So 0 1 1 0, 0 1 1 1, 0 0 0 1, and 0 1, sorry, 0 1 0 1 and 0 1 0 0. So this got me answer for n is equals to 4. So I hope I am clear. Like, what we are doing is we are traveling in reverse and changing zeros to ones. Like for example, when creating for n is equals to 1, I was changing this bit. Then for n is equals to 2, I was changing this bit. Then for n is equals to 3, I am changing this bit, and I am traveling always in reverse direction. So let's code it the solution now. I am given int n and c in n. So next is like, let me create a string s of size n with zeros, and let me create a in vector string answer, and answer dot push back as. So currently my answer is having one string, and I will create a count, and since we have to stop, so when there are 2 to the power n strings in the array, so this is for the counter. So currently I'm having one, so that's why count is initialized as one. Now while count is less than limit, since count is less than limit, so now what I have to do is I have to start from the back of the array. So for int I is equals to answer dot size minus 1, I greater than equals to 0, I minus minus. Now I am standing at the back of the array. Now what I have to do is I have to just push back answer dot push back array, answer of I. So I will push back this ith element, and now I will just answer dot back. In C++, answer dot back gives. So here I need to introduce one another variable also, int bit pause. So bit pause is initially n minus 1. So yeah, uh, bit pause, since this is the bit position number which I need to change, is I will change the last position to 1, and then count plus plus, and coming to here I will just now reduce the bit position, because in the next iteration, as we see here, and now bit, let me tell you once again what is bit pause. So bit position is initially n, since you can n minus 1. If I have n is equals to 4, so in string this will be third index. So bit position is n minus 1. So while we are doing it for n is equals to 1, so I am changing this bit. Then after n is achieved, then for next n, bit position is reduced. That means in the next iteration I have to change this bit, then in the next I have to change this bit. So that's what bit pause is indicating. And after each incremental value of n is achieved, we are reducing bit pause for the next iteration. And answer dot back directly gives me the last element of the array which we have pushed. So that's how it works. Let me just print the final answer for auto and I in answer. Cout I, and so let's check for test cases. Yeah, so for 1 it is perfectly fine. For 2 also it's working. For 3 also it's working. For 4, yes, we can see for 4 also it's working. So let's submit it. As you can see, it got accepted. So like, you must be wondering like how to think in this direction. So let me tell you something about this. Since we are given a test case for 2, for n is equals to 2, I have 0 0, 0 1, 1 1, and 1 0. So what I initially thought was like all the bits at this place must have been 0 till now. But now for to calculate for n is equals to 3, what should be my aim? Like I cannot change these two bits after n is equals to 2. I cannot change these two bits, because if I change, then these numbers are already there in the series. So the only bit which is remaining, which I can change, is this one. So I started by changing this bit. Okay, now I got this. Now I cannot change this bit, and what I observed is like gray code was in this direction, but if I check in reverse order, then also it's gray code. For example, n is equals to 2. This is also gray code, 1 0 1 1 0 1 0 0. In reverse order also, since there is only one bit changing, so it's also a gray code. So what I thought was like, keep the, now I cannot change this bit because I just changed it. So I just keep this bit constant and just reverse this part. So 1 0 1 1 0 1 0 0. So yeah, I hope now I am much clear with my explanation here. So that's how we solve it, guys. Thank you for today's video. And yeah, it got accepted as well, I showed. Thanks.